So this morning you heard Sandy talk about data cooperatives, and Sandy has this ability to explain in 3 minutes what I need to do in 20 minutes. So it's good that you guys had a quick intro about the background and motivations about this. So basically, what is a data cooperative? So the original idea we looked at was the credit union. So if you go to a credit union, they talk about their constituency as members, not customers. They make a point about that. And I've met with a number of credit unions, and they use the word member, which is kind of good. So could we have a data cooperative where individuals would get together, pool their data as a pooled set of resources, and use it to their own benefit? So imagine an organization, just like a co-op. Everybody's got a data store, and then the individual still has the option to opt out. So even if you have the data store there, they could say, yes, I give consent for something, right? So we can talk about what consent here means. And in order to preserve the privacy of the personal data, it would observe the open algorithm set of principles, which is move the algorithm to the data never leaves the repository. You always default to safe answers, aggregate answers, and only run good algorithms, vetted algorithms. Right? So those are the three things. And so there are a number of use cases. Sandy talked about providing visibility to the community members. So there's the Uber driver example. You guys remember today, the Uber drivers in East Boston are getting a different amount of money than the Uber drivers in, on average in West Boston. So what if you could have, the Uber drivers get together and the Uber riders like ourselves, and share data in this sort of legal construct. And the important keyword here is that the organization has first and foremost fiduciary obligations to the membership, not to the customers. So in the first instance, it could run what I call just internal analytics. So another example, so we were talking with, we've spoken to, of course, MIT Credit Union, Vermont Credit Union. We're also talking to the trade unions. But what if an organization like a trade union could negotiate better healthcare rates, better insurance rates? What if the data co-op in Cambridge discovers that 12% plus of its membership are young family with children? So they could turn around and go to Costco and negotiate a better deal for diapers. So instead of giving cash, money, give them immediate benefits that they can, choose to take or not take, right? So that's kind of the basics. And so diagrammatically, it looks something like this. So the data cooperative, the assumption here is that the ordinary citizen does not have the capacity to run their own servers or personal data stores. So, and by the way, most credit unions in the United States actually outsource their IT infrastructure management anyways. So they're used to the idea. So what if they could, host and curate and manage the personal data belonging to their members, right? So the gray side here on the right-hand side is, data that's hosted at the cooperative, and let's say there are a group who are, choosing to host it elsewhere in their own data store, on Amazon, on Dropbox, doesn't matter, and that's, on the bottom right-hand side. But the functions that we want to have in such a system would be consent management. So it's always opt-out. And in this case, consent means consent to run an algorithm. Because if you read something like GDPR, it says consent to do what? Does it mean consent to read everything I have? It should read consent to perform something specific for a specific purpose for a duration of time, right? Vetting algorithms need to be vetted, of course, and managed, meaning that maybe there's version 2 of the same algorithm and so on. Data location management, of course, comes along with the distributed nature of the whole scheme. And should we end up looking at encryption, then you will need to manage the shards, the pieces of the encrypted data in the distributed network. And of course, identity and access management come into play. That's also quite important. Now we have actually pieces of the software implemented. So a bit of background, one of the things we do in our group is actually write open source software for the benefit of our sponsors. And the idea is that you guys could play around with it, and it's kind of, well, better than student grade software, but it's not, it's not corporate grade software. So if you guys choose to productize it, great, it's MIT licensed, so run with it. So we have an Opal server, courtesy of Justin back there. So he's our Opal server guy, and we do have a semblance of a personal data store server from ages ago from previous students. So we have code for that. We definitely have the code for the identity and access management. It looks complicated, it's not. So Alice, step number one, Alice, who's the member, needs to go in and set her policies. So I only want my GPS data to participate in any Opal algorithm execution. I don't want my health data involved. So things like that, very granular, because the ordinary user really is limited in the understanding of the types of data. Then Bob comes along. So let's say Bob is I don't know, it's a Costco. Costco says, we want to know what percentage of your members, shop at Costco. What percentage of your members have children under 5 years old? Something accurate, right? And so Bob has to authenticate, gets a token, an access token, not a crypto token. We can talk about crypto. We were just talking about crypto tokens. And then once Bob is authenticated, provides a token to the Opal server in step 3, the internal exchange occurs, the algorithm and the token is given to the endpoint to be executed, the answer comes back, and then at the last stage you have safe answers. So we have the software for the Opal server, the PDS server, we have an identity server, which is the OpenID Connect server. It's the same protocol used by Google, Facebook Connect, Twitter. It's just a WAF with a few other extra bits. So if you guys know what I'm talking about, we actually have a pretty good, pretty complete, spec-complete implementation of that software. And it has been run continuously in a couple of enterprises for 3-4 years nonstop. So that's production quality, that particular piece of software. So that's kind of the project that we have. One of the things we want to do is partner with one of the sponsors, Twitter sponsor, perhaps with one of your customers. So I like this triangular thing. I think it's a successful model where we as Connection Science work with a sponsor with one of your clients, because then they're happy, and if the client's happy, you're happy, right? And if you guys are happy, we're happy. It sort of proves that, okay, I'm doing my job. So yeah. But anyway, I think that's the end of the slide. Yeah. Any questions?